Over the past several years, I, like many of you, have spent a lot of time inside and decided to try my hand at baking. After all, it involves a lot of science. Combine several ingredients, follow a standard operating procedure, add a little heat energy, and you've got a beautiful cake. Easy, right? Wrong. Baking was not, in fact, so easy for me. However, I did learn just how important it is not only to have the right ingredients, but also to have them in the right proportions. This isn't all that different from how things work on a coral reef. Instead of ingredients like sugar and baking soda, corals rely on things like light, temperature, and salinity. Saltwater around the world weighs in at about 35 parts per thousand, and under well-mixed conditions, this stays pretty consistent. Through human action, things like climate change and freshwater management are threatening to change that. Climate change increases the likelihood that we'll see a lot of rain and see it all at once. Then, through the use of tools like dams and canal systems, like those associated with Lake Okeechobee, we're able to hold that water and then release large amounts of it over a short period of time. This is a common phenomenon that takes place on a reef known as St. Lucie Reef, just outside of the St. Lucie Inlet. Although this reef is colonized by very hardy coral species, we still see increased signs of stress in response to freshwater release events. My master's thesis research aims to characterize the extent to which these corals are impacted by these freshwater releases. To do this, we've set up 6 aquaria, like the one in this picture in the middle. We'll collect 3 species of coral, we'll fragment them and place them in each tank. We'll then begin the first experiment, in which we'll reduce the salinity by 2 parts per thousand each day until we find mortality in 50% of the fragments of each species. This is an LC50, or a lethal concentration for 50% of the population. We'll also be taking coral health assessments as well as tank pictures daily, just to keep an eye on how the corals are doing overall. We'll use this information to help set up a second experiment, in which we'll reduce the salinity of experimental tanks to a predetermined intermediately stressful salinity. This will help us understand just how long these corals can endure a sublethal salinity stress. Overall, the information gained from this experiment, these series of experiments, will help us not only to understand what we can expect of nearshore coral reefs in the future as the climate continues to shift, but will also help to inform local managers on how best to release this water in a way that limits coral stress and mortality. We're confident that with this information, we can create the perfect recipe for reef health and preserve corals for decades to come. Thank you.